Yeah, hand over to you.
All right, cool. I don't know if looks like we're recording. Sounds good. All right, cool. Well, thank you all for joining. Thanks for taking some time out of your weekend. I know it's a little busy. We all were probably looking forward to relaxing, but thanks for coming. My name is Mitch Spano, and today I'm going to be sharing a presentation called "Orchestrate All of Your Salesforce Automation with the Salesforce with the Trigger Actions Framework." Now, hold on just one sec. I might want to close this stuff. Okay, so about me. So my name is Mitch Spano. I'm a 16 times Salesforce certified application and systems architect. I'm an application engineer at Google. I've been involved in the Salesforce ecosystem since 2013, so got about 8 years of experience. I like to consider myself an overall good guy. That's just a nice little bullet point that I put in there. You can find me on Twitter at Mitch Spano. It's probably the easiest way to reach out to me. You can also reach out to me on LinkedIn. So if you have any questions about this presentation, it's going to be recorded, so you'll be able to review it for some reference material. But if you have questions particularly for me, like I said, reach out to me on Twitter is probably the easiest way to get connected. Cool. So who are the intended audience members for this talk, right? So this talk is pretty cool. I'm very excited to share it. But if you're an architect, right, we're going to be learning about a really cool trigger framework. And I want you to consider how utilization of this trigger framework could help you and your organization scale to support much more users and many more even teammates, right? Many more developers, architects, admins. And I want you to take a look and keep your eyes open for some strategies that'll help you to partition your application. There's some cool stuff in here that'll definitely help with that. If you're a developer, right, I want you to think about how utilizing a framework like this can help you to implement code faster and higher quality code. It's really, there's going to be some things in here that which I think that you might find liberating from the previous generation of trigger frameworks. Also, there's some really cool stuff about how to write unit tests for code that you will be that can be used in this trigger framework. So stay tuned for that. If you're a manager, or if you're like a system administrator, or maybe you are in charge of a Salesforce team, and you maybe writing triggers is not something that you do in your day-to-day life, you're going to probably understand you'll be able to get a better understanding of what it means when somebody says, hey, we need to write this logic in a trigger. So you'll understand a little bit more about the complexities of what it comes with writing triggered logic. And then I also want you to think about how utilizing something like this can help you to manage multiple teams in your Salesforce environment, right? So when it comes to Salesforce, we have many automation tools, right? So Salesforce is all about business process automation. And certain tools that we have on our fingertips are a little bit more powerful than others, right? So you could have no process automation, where you basically are using Salesforce as just like a data store. You could use workflow rules. Workflow rules are helpful for updating field values or sending email alerts. You could use process builder, which is like a little bit more powerful than workflow, but it can do similar tasks. And then you can use Flow, and there's been a lot of investment in Flow in the Salesforce platform, particularly over the last 1.5 or 2 years or so. But when it comes down to it, Apex triggers are the most powerful thing that you have, the most powerful tool in your tool belt when it comes to creating process automation within Salesforce. But as the level of power increases, so too does the level of risk. So you don't necessarily just want to write everything in a trigger, but there are certain scenarios where, a trigger, where you want to write all of your logic into a trigger. You're only supposed to have one of these automation tools per S object in your org. So sometimes if you need to write any trigger logic at all, it means that you should write only trigger logic. And with that increased power comes increased risk and a little bit of increased cost too, because then you have to have a developer to write it and maintain it. And the value proposition of the Salesforce platform gets a little bit diminished when you just have to write code anyway. So I'm really excited to share this framework because it's going to help you to decrease that long-term cost of ownership of your trigger logic. So trigger logic can get messy, right? So whenever we write triggers, we have like an object and a context right? So let's just say we have opportunity objects, or after insert on the opportunity object, then we check some field values for the collection of records that have just hit the database, right? So is the record type wholesale? Is the owner a Q? Is the state Minnesota? Whatever it is, right? And then we take some actions based on those field values. So maybe we need to update the parent account, or maybe we need to notify some sales team or some director, or maybe we need to make a call out to another external system, right? All of this stuff needs to reside in your trigger, and it can get kind of messy to maintain and own all of that. So with the existing legacy trigger frameworks, they offer you this mechanism by which you extend a trigger handler class, and then you can override one of these context-specific methods. So for example, here we're on the opportunity trigger handler, and we're extending the normal trigger handler class. And then we implement our logic in the after insert method, right? And this has worked great. Honestly, this has really worked well for a long time, and it really helps you to separate your logic from the calling trigger. And then within the trigger handler itself, you have complete control over the order of execution. The thing is, though, is when you implement logic, you implement it within the body of these context-specific methods, right? So even if you had this as perfectly simple as it possibly could be, right, where you just have these one-liner method calls, you pass the trigger.new or the new list into these private methods and then handle all of your logic from there. The problem is that every time you need new logic, you need to modify the trigger the trigger handler itself, right? And keep in mind, this is super clean. This is really, really well architected. You can tell that the pattern has been followed. There's been a lot of thought that's put into this. If I came into a Salesforce project and I took a look at their triggers and they were written like this, I would applaud whoever came before me, because they did a fantastic job. But the problem is like I said, it just continues to require additional modification for all of your new trigger logic. So eventually, what happens is your after insert method just gets longer and longer and longer. And like I said, you're supposed to only have one automation tool per S object. So that means that you're going to have all of the teams who manage automation on opportunity S object must be responsible for maintaining this opportunity trigger handler class. So there's this one class that has this multiple responsibilities, and it's owned by multiple teams, and it requires modification time after time after time. And you can do it where it's clean and simple like this, where you have these one-liner method calls and you control their sequential execution, but it still is less than ideal. There are also some other things about the existing or legacy trigger frameworks which are a bit less than ideal, right? So for example, if I wanted to, test the recalculate account values method, for example, I would actually need to insert an opportunity. And when I insert an opportunity, I'm not just testing that the recalculate account values method works the right way. I'm also testing that the opportunity doesn't break any validation rules, that all process builders work correctly, all workflow rules work correctly, all flows work correctly. Any of the other previous logic, such as handle retail insert or handle wholesale insert, in this case, all of those must pass successfully. So there are multiple different opportunities where your test can break that don't have anything to do with the recalculation of the account values. So you're not really doing a unit test when you test trigger logic and using these existing frameworks. You're kind of doing more so like an integration test, where you're testing all of the stuff that happens when the opportunity hits the database and then making assertions about one particular action of the subset of all of those actions that happen. So these are some of the goals or some of the issues which I wanted to resolve when I originally started writing what I'm calling the Apex Trigger Actions Framework. So take a look here. You can take a screenshot of this QR code, or you can go to this GitHub link. Maybe I'll be putting that in the chat in just a moment. We'll also be taking a look at the README for this GitHub repository as well throughout this presentation. And all of the topics that we're going to be discussing today are present in the README for this particular repository. So anything that we talk about, you should have some reference material to go back to at a later time. Take a look at the recording, take a look at the README. You should be able to get most of your answers, most of your questions answered. So the Trigger Actions Framework seeks to solve all those problems which we just talked about, And here are the parts of the trigger actions framework. Here's the architecture, right? We basically have these 3 main classes and these 2 different types of custom metadata. And I'm not going to go into detail about this. I'll give you a little bit of a high-level definition of the responsibilities. The trigger base handles all of the normal trigger things for dispatching trigger events. So like if is after insert, then call after insert, is after update, then call after update, right? The trigger action is just a wrapper class which contains these interfaces for you to implement. And then the metadata trigger handler is really where the magic happens. There are these 2 different types of custom metadata, the S-object trigger setting and the trigger action. And we'll get into the details about all of this, but the metadata trigger handler is what really does all of that, all of the work. Now, the cool thing about the trigger actions framework is you don't really need to know about any of these. You don't ever need to modify the trigger base. You don't ever need to modify the metadata trigger handler. You don't ever need to modify the trigger action itself. In order to implement things using the trigger actions framework, what you do is you just create an individual class that implements the correct interface, right? So the trigger action opportunity stage insert rules implements trigger action before insert, right? Then we use custom metadata to actually plug in and act as the controlling mechanism by which we say this one should go first, then this one should go second within the before insert context. So this is kind of the overall architecture. Don't want you to get too bogged down in it. It's kind of hard to read on these slides because it's a little zoomed out. So I'm gonna hop out of presentation mode here. And let's see if I can minimize that. Nice. Okay, cool. So I've got right here a scratch org opened, and I've also got the README, like I had said, for the trigger actions framework GitHub repository, right? So we'll be hopping back and forth between these. But what I did is I cloned this repository, right? I created a scratch org. I pushed the repository to the scratch org, and then I made these 2 additional modifications, right? So here's the repository. I'll zoom. Here's the contents of the repository. Here's the project itself. And git status, right? We took what's on the master branch and then we added a few things, right? We added this opportunity trigger, which is just a 1-liner trigger. And then we authored this new class, called TA opportunity stage insert rules, right? Now, this is like, these are kind of the building blocks, right? And what we've done is we took the contents of the trigger actions framework, we installed it, and then we made these 2 modifications and we pushed these also to our scratch org, right? So I'm gonna go back to the scratch org, right? And in order to enable the trigger actions framework, there's one step that you need to do. So you do this 1-liner trigger on the S object that you're interested in. Then you come back and there's these 2 custom metadata types I was talking about. There's the S object trigger setting. Let's zoom in a little bit, make this easier to read. There's S object trigger setting, which corresponds to the object itself. So let's create a record in S object trigger setting. I'll create a new one, and it's going to be called opportunity, right? Like I said, it just corresponds to the object itself. Here we enter in the object API name. And if you're using an object that's part of an installed package, you might need to enter in a namespace. So here's where you'd enter in the namespace for a third-party package object. Now I'm going to press save. So this means now the trigger actions framework is enabled on the opportunity S object because we did that 1-liner trigger itself, and then we created the S object trigger setting. Okay, cool. So now let's take a look at our stage insert rules class. So the idea here is we just wrote this small individual class itself, trigger action opportunity stage insert rules. And we write it where it implements the correct context, right? So it implements trigger action before insert. And the scope of this class is pretty minimal, right? It just does this individual thing. So it says before insert for every opportunity that we have that's new, if the stage name does not equal prospecting, then we're going to add an error that says the stage must be prospecting when an opportunity is created. Okay. Now this class by itself has no injection point, right? There's nothing that would actually call this. And that's where the trigger actions framework comes in handy, right? So now we're on the S-object trigger setting. You'll see we have these related lists, and there's no records in them right now. These are metadata related lists. So we have before insert, before update, after update, basically all of the different trigger contexts that you could be in. So I'm going to go back to custom metadata. And what I'm going to do now is I'm going to enable this trigger action by creating a trigger action record that corresponds to that class that we just authored. So a new trigger action record. And what you do is you take the name of the class, and that's where you put it into the Apex class name. I'm also going to have that be the same for the label. So trigger action opportunity stage insert rules. The order is it's going to be the first thing that happens, and then you specify the context in which it happens. So it's going to be the first thing that happens on the opportunity S object. So this is why we need that S object trigger setting. These lookups point to that S object trigger setting record that we just inserted. So if I try to save this, right, I'll get an error. The error says, you must enter a description for this trigger action. So no longer can your developers write code without telling other people what it does. So prevents the opportunity from being inserted unless the stage is prospecting. All right, cool. So we'll save it. Cool. So just a quick recap, right? We installed the trigger actions framework. We wrote this one-liner trigger itself. We made the corresponding S object trigger setting record. We wrote the class for the trigger action, and then we made the corresponding trigger action record. Now, if we take a look back at the S object trigger setting, we'll see before insert, the first thing that happens are the stage insert rules, where we prevent the opportunity from being inserted unless the stage is prospecting. So let's go to opportunities, create a new one, my op, right? Say it closes today. And let's just say the stage is closed one, right? Put it in, it's closed one automatically. Press save. The stage name must be prospecting when an opportunity is created. So, so the cool thing about this is we just wrote this individual class that does that individual thing, right? It's got one responsibility, and we never needed to go back into the opportunity trigger handler and then call this method, right? The calling of the methods and the order in which they're called is handled via that metadata itself. And we get this universal view on the S object trigger setting of all of the actions that happen on the opportunity S object. So now if I take this and I put it into prospecting, press save, there we go. The op was created. So with the trigger actions framework, the act of extending your trigger logic no longer requires modification of the opportunity trigger handler per se in this particular example, or whatever S object trigger handler you're talking about, case trigger handler, account trigger handler, whatever it is. You no longer need to go back in and modify that class. All that you need to do is write the individual class which implements the correct interface for the one particular action you're trying to take. And then we go and we use custom metadata to determine the order of execution. I'm gonna get out of full screen because the little Zoom meeting thing keeps messing up with my real estate here. Cool. So this works as a really, really effective mechanism for us to partition our trigger logic. And then we get this nice universal view of everything that goes on in order on the opportunity S object. So let's just say we had a different action that needed to happen before insert. Let's write it. So I'm going to create a new class, right? TA opportunity, name hello. Okay. So, oops. Let's copy this one, paste it in here, change the name to name hello. Right? Hello is our constant, right? Right? Before insert, for every opportunity, op.name equals hello. So now we've just written a different trigger action. Let's push to sort. Let's push source to the Scratch org. Make sure that this gets deployed correctly. All right, looks like it was good. Now head back over into Salesforce. I'll go to custom metadata types. I'll create a new trigger action record itself. What we'll do is we'll grab the name of the class that we just authored, TA opportunity name hello. That's the name of the Apex class. And let's say that's the second thing that happens before insert on opportunity. Give it a description, sets the name to hello. Now we'll save it. So now when we take a look at the opportunity S object trigger setting, we'll see these are the two things that are happening before insert. We're gonna first prevent the opportunity from being inserted unless the stage name is prospecting. Secondly, we'll then set the default name to hello. So if I go back into opportunities, I'll create a new one. I'll give it the name of my second op, right? Close date of today. We'll try to insert it in closed one, save. Stage name must be prospecting when an opportunity is created. So we know that that first trigger action is still actually working. Now let's put it back into prospecting and I'll press save. Now we should get a default name of hello. So again, the act of extending your trigger logic no longer requires modification of the opportunity trigger handler per se. All that you do is write the individual class that does whatever you need it to do, and then you specify using the custom metadata itself the order in which the class executes in the given context for the given S object that you're working on. I'm gonna take a pause here. I'm just curious if anybody on the meeting happens to have any questions about the moving parts. So the metadata types, the individual Apex classes that you write, using the order of execution.
We are good.
Chat, let's see here. So one custom metadata entry per Apex class. What does implementing the trigger action provide the bridge between the Apex class and the custom metadata? I will talk about that in just a little bit when we kind of take a peek underneath the hood. Do we need to configure the metadata trigger handler? Nope, metadata trigger handler, you'd leave it alone. So much better. Framework for preventing recursion scenarios, right? So recursion, that's a great call. If you take a look in the README, right? So within the trigger base class itself, there are these two static variables, ID to number of times seen before update and ID to number of times seen after update. So these will give you a map, basically an occurrence map of how many times have you seen this particular record. So you can say, if the ID to number of times seen after update for this particular ID equals 1, then we know it's the first time that we've that we've seen this record, and then we can choose to process it. Or if it's greater than 1, we can choose to omit it from processing because we don't want to recurse. So there's built-in recursion prevention into the framework itself. Another thing that I want to talk about that's pretty cool about this framework is some bypass mechanisms, right? So if you take a look at the S-object trigger setting, there's this little checkbox for bypass execution. There's also a corresponding checkbox on the individual trigger actions themselves, bypass execution. So let's just say I'm going to go back to the name hello. I'll press edit, and we'll check this bypass execution checkbox. Now that means that the name hello trigger action is really no longer active. So if I go in, let's create a new opportunity. My third op closes today. I'll try to insert it in closed one, and we'll see that the stage name still must be prospecting when an opportunity is created. So that first action is still executing. But if we do change the stage name to prospecting, and I press save, the name is still my third op because we bypass the execution, which would set the default name to hello. So you have a nice checkbox mechanism to turn off individual actions or all of the actions on the trigger itself. This is basically like deactivating the trigger using the bypass execution checkbox on the S-object trigger setting itself. These are nice. They're super helpful, particularly if you want to turn off an individual piece of functionality without turning off everything, or if you want to deploy something and then activate it at a later date. They're definitely helpful. But sometimes it's not exactly what you want, because these are kind of like global bypasses, right? They'll stay bypassed until you turn them back on. There's a second way in which you can bypass. So what I'm going to do is I'm going to go back in and I'm going to turn that name hello one back on. I'll remove the bypass checkbox. All right. So press save. Okay, so now both of those actions are active. Let's open up Developer Console. And let's open up an anonymous window and let's create an opportunity. Opportunity myop equals new opportunity. All right, myop.name. My opportunity, right? Let's give it a close date. Oops. myop.close date equals date.today. All right, and let's give it a stage name. myop.stage name equals qualification. All right, now insert my op. All right, and then what we'll do is system.debug. And we'll query for the field values on the opportunity after we've inserted it. Whoops, select ID. Whoops, ID, name, stage name from opportunity, where ID equals myop.id. Okay, cool. So let's make this a little bit more readable. Okay, so if I execute this, right, the stage name is a qualification, so this should fail. Stage name must be prospecting when an opportunity is created. Okay, but what we can do is we can use the metadata trigger handler class to bypass an individual action. So we could say metadata trigger handler dot bypass, and then you pass in the Apex class name that you want to bypass. So in this particular class, in this particular instance, let's bypass the stage insert rules. And this is like a static bypass. So this bypass will only remain active for the scope of the individual transaction. So we're bypassing the stage insert rules, which means that it's okay that the stage name is qualification. So I execute this. we'll take a look at the log, and we'll take a look at the debug, which gets printed out. We'll see that the name is hello and the stage name is qualification. And we did not receive an exception when we inserted the record because the stage name was not prospecting. We were able to bypass that particular individual trigger action, but it's only for the scope of the transaction. You also then can clear the bypass, right? So we could say metadata trigger handler dot clear bypass. You could say clear bypass for an individual name, or clear all bypasses to clear everything that you've bypassed. So we could then clear the bypass for this, and that would mean that any subsequent opportunities which get inserted must adhere to these stage insert rules. So you can use the bypass checkbox on either the individual action itself or the S-object trigger setting to do a global bypass, where it's like, this is going to stay off until we turn it back on. You can use the metadata trigger handler class to bypass an individual action, or you could use, and then you can also clear the bypass for individual actions or all things that you've bypassed, or you could use trigger base dot bypass, and you can bypass everything on an object. Right? So bypass all the stuff on the opportunity. So now when we do this, we should see that the name is still my opportunity and the stage name is qualification, right? We execute that. Let's take a look at what gets printed out in the debug log. Name is my opportunity, stage is qualification. So you can use metadata trigger handler or trigger base to bypass all of the actions on a given S object or an individual action for the scope of a transaction. And you can also clear those bypasses so that way you can turn them back on for subsequent actions that are taken within that transaction itself. So there's the global bypass with the checkbox that'll stay bypassed until you turn it back on. There are these static bypasses, which will stay bypassed until the transaction is complete. And there's a third bypass mechanism in the trigger actions framework itself. So if you take a look at the S-object trigger setting, there are these two fields. There is required permission and bypass permission. Now, these are also present on the corresponding actions themselves. There's bypass permission and required permission. So if I enter in using bypass permission, how this works is you enter in the API name of a custom permission. And then if the running user has that custom permission, then this individual action or the whole S object themselves will be bypassed for that particular user. So this is super helpful for, let's just say you have a data integration user, and the data integration user is not supposed to run automation on the opportunity S object. They're just supposed to dump opportunities into the system and let it be. Right? There's also the required permission, which is kind of the opposite of the bypass permission. The required permission means that this trigger or that individual action will only run if the user has that particular permission. So this is super helpful for if you are writing some new features or some new capabilities within your system, and you want to do like a beta test. Then you can use this required permission, create a custom permission and assign it to your users. And then only the folks with that permission will have those triggered actions be implemented for them. Then when that beta test goes live to production, when it gets rolled out to more users, you simply remove the bypass permission that you've configured on the metadata itself. So I'm not going to demo those, but that's the third bypass mechanism for the trigger actions framework itself. So let's take a look at the chat, see if we have any additional questions. Trigger bypass, is a trigger base separate action variable? Let me see here. Trigger base separate action variable. I think the trigger base bypass is separate from the metadata trigger handler bypass. Trigger base bypass is just for the S object level. Trigger action metadata trigger handler bypass is for the individual actions themselves. Questions. Creating Apex classes for each requirement would not hit Apex limit in org. So your Apex limit in your org is determined by the overall number of lines of code, not necessarily the number of classes that you have. How to bypass all trigger action in Apex class. Yep, that's how we do that. Can we also bypass for test classes? Yep, you can bypass for test classes, bypass for a specific user using the bypass permission itself. Cool. So the bypass mechanism, I think, are personally they're one of my favorite parts of the trigger action framework. I think that they're very, very helpful. And you know, we've got a lot of good stuff here. So far, we've been able to partition our trigger logic. We've been able to write classes that have a single responsibility. We've been able to control the order of execution. We've been able to bypass things. All of these are great. And you know, I'm super happy to share all of that with you guys. When I started writing the trigger actions framework, I had shared it where we were just talking about partitioning the trigger logic itself for your Apex classes. And I had a colleague who said, you know, Mitch, this is awesome, but I wonder if you could make it work with flows. And at the time, I didn't have it quite figured out. But here's another cool thing about the trigger actions framework is the trigger actions framework will allow you to author flows and then plug them in as individual trigger actions. So you can say, I want this Apex action, then this flow action, then this flow action, then this Apex. And you can control the order of execution of flows amongst Apex itself, which is something we've never had the capabilities to do in the Salesforce platform. So let me show you guys how we would do that. If you write these flows, there's a little bit of a learning curve with the flows, because you're writing flows that are operating on collections of S objects instead of an individual record. So we'll go to flows, and you need to write the flows in a particular way, and you'll be able to catch on. It's actually pretty easy once you get it. You're kind of writing a flow like you would write a trigger. So let's create a new flow. And if you want a flow to be able to be used within the trigger actions framework, you need to make it an auto-launched flow. So here's an auto-launched flow. It's a free-form flow. Now, let's do a flow where, for this particular flow, what we're going to do is we're going to give the opportunity a default name of goodbye before insert. Now, we need a couple of variables when we do this. So the first resource that we're going to do is a variable, and the API names of these variables are specific. And this is actually documented pretty well here within the README itself. So if you go down to the support for flows section, you'll see the variable names and what their types are, if they're available for input or output, and a little bit of a description. So the variable name that we need in order to set a default name for an opportunity before insert is new list, right? This is a record collection of opportunities, right? That is available for input. Now, this new list basically contains the contents of trigger.new. Okay, that gets injected into the flow by the trigger actions framework itself. Now, you also need one more resource, which is a variable. We call this the new list after the flow is complete. So after flow, new list after flow. Now, this holds the state of the new list after the flow is done. So what we do is this is a record collection of opportunities that are available for output. Okay. Now, well, what are we going to do? First thing in our flow is we're going to loop over each record for each record, right? That is in the new list. For each record that's in the new list, let's assign the record a new name. Set name to goodbye. Whoops, goodbye. So the current record's name equals let's create a new resource that is a constant called goodbye. That is text, and the value is goodbye, right? There we go. So for each record, we set the name to goodbye. Now the final stage of the loop is we need to store the state of the new list after the flow is complete. So we add the record to the new list after flow. So we're going to say new list after flow. We're going to add the current records itself. Okay, cool. So here's our flow. We're setting the name to goodbye, and then we add it back to the new list after the flow is complete. Pretty simple flow. It's an auto launch flow. We'll save it, call it the goodbye flow. All right. Now it's saved, but then we got to activate it. Okay, cool. So now this flow is created, it's activated, but nothing's kicking it off. This is where the magic comes in with the trigger actions framework. So let's go back to the setup menu. We'll go back to custom metadata types. We'll create a new trigger action record itself. Now this trigger action, we're going to call it the goodbye flow. Now you enter in the API name of the flow under flow name. And let's say this is the third thing that happens before insert on opportunity. Now, if I enter in some bogus class name, so sets name to goodbye, right? If I enter in some bogus class name, then Apex class must equal trigger action flow if the flow name is populated. So the trigger action flow is the name of the Apex class, which will enable flows to get launched using the trigger actions framework. So now I save it, and we'll take a look at opportunity itself, the object trigger setting. We'll see that these are all of the things that are happening in order. First, we prevent the opportunity from being inserted unless the stage name is prospecting. Secondly, we give the name, sets a default name of hello. And then thirdly, we set the default name to goodbye. So if we go back in, let's create a new opportunity, right? My fourth op closes today. Stage name is closed one, should fail. Stage name must be prospecting. Okay, that's great. So now we put it to prospecting. Now, if we take a look at the order of which these things happen, the name's going to get set to hello, but then it's going to get overwritten by the flow and get set to goodbye. So let's insert it. There we go. The opportunity's name is now set to goodbye. So you can use the trigger actions framework and write your flows in a way such that they can be plugged directly in, and then you can control the order of execution. So if I went here, let's just say that this one is, let's swap the order, right? 3, and then I go back in and I set this one to 2. Right, so now it says goodbye and then hello. So now if I insert a new opportunity, my fifth op closes today. Stage name is prospecting. It should get set to goodbye and then overwritten with hello. There we go. So you can use the trigger actions framework to bridge that gap between the programmatic side of Apex-based record automation in Salesforce and the declarative side using flow, and maintain that control, or the complete control over the order of execution itself. So here we know that we can say the name gets set to goodbye and then it gets set to hello. We know we control which Apex runs first or which flow runs first. We don't delegate that to the platform. The lack of control of the order of execution of flows has been quite challenging for a long time for many folks. And there's been such heavy investment in flows, and they're super powerful. So you really do need a mechanism like this in order to control the order of their execution. And I think that being able to say this Apex gets called, then this flow gets called, then this Apex gets called is super, super helpful. You still also have all those same bypass mechanisms, right? So you can bypass the individual action itself, or if you go into if you you're writing Apex, you can say trigger action flow dot bypass, and then pass in goodbye flow. Pass in the API name of the flow itself. So those Apex-based bypasses also still work by using trigger action flow dot bypass. You still have those permission-based bypasses, right, on the flows, and you also have those checkbox kind of global bypasses for flows as well. You also can, within flow itself, you can create an action. There are a lot of Apex actions that are included in the trigger framework, such as bypass, right? So then you could say bypass. The bypass type, you would put in object to bypass everything on a given object. You'd put in Apex to bypass an individual Apex action, or you put in flow to bypass a particular flow. And then you enter in the API name of the object, the Apex, or the flow itself. And then you can kick off the bypasses from flow as well. So all of the things that you have the capabilities of doing for bypass mechanisms that are available on the Apex side are also available on the flow side. So let's take a look at the chat. Trigger action flow out of the box. No, trigger action flow is part of the framework itself. Let me see here. Cool. There's one other thing that is so like when we write these flows, they're auto launch flows, and auto launch flows have a little bit less capabilities than you would hope for. Like, so record-based flows, you can do things like prior value or is changed. In an auto launch flow, you don't have that capability. However, the trigger actions framework includes some really cool, like I said, some Apex actions which can help you to do some things like that. So let's create a different flow. And this flow, what we're going to do is we're going to, when an opportunity gets updated, check if the stage has changed. And if the stage has changed, we'll give the opportunity a default description. Okay. And I'll show you how to write the flow. Again, it's going to be an auto launched flow. Right? We'll go freeform. Now we're going to need to create some of those elements that we had previously. This is a variable called new list, right? It's a collection of records that are opportunities that is available for input. Okay. Now we'll create a new resource that is a variable called old list, which is a record collection of opportunities as well. So new list and old list, they just basically contain the contents of trigger.new and trigger.old. And those are injected into the flow using the trigger actions framework at runtime. So this is available for input. Okay. And then we need the new list after the flow is complete, right? So we create a new variable, new list after flow, right? Now this is a record collection of opportunities that are available for output. Okay, so those are our variables. Now, what do we want to do, right? So just quick recap. We want to say if the stage name changes on an opportunity, set a default description. So what are we going to have to do? Let's start off with the loop, right? For each record. Now, for each record that's in the new list. That's where we'll start. Now, what we need is we need some way to capture the old record values, right? Because we're iterating over the new list, but we want to compare for this given record, what did it look like in the old list? So let's create a new resource, right? This is a variable that is the old record, right? And its data type is a record. It's not a collection, it's just an individual opportunity. And it doesn't need to be available for input or output. Now, what we do is we call an Apex action. There's an Apex action called get old record within trigger action flow. So get the old record, right? Now you need to pass in the object types. The current record is an opportunity, the old list is an opportunity, and the output that we want is also going to be an opportunity. Now set the input values. The current record is the current record that we're looping over. right? The old list is the old list of opportunities. And then we check down this advanced checkbox to manually assign the output of this Apex call to the old record itself. So now we've called this Apex, and this Apex itself, it just traverses the old list to find the old version of the record. We're not making any queries. It's totally safe to do in a loop. But this is a really, really nice way for us to fetch the old version of the record. Now we can make a decision, right? Did the stage change? Right? So stage changed. Right? If the stage changed, we'll know that that's true if the old record's stage is not equal to the current record's stage. All right. So if that's true, so now we've got the old record, we know what happened. If that's true, we're going to give the opportunity a default description, set description. Set description. Oh, whoops, that's a decision, not an assignment, excuse me. We need an assignment, set description. All right, so what we want is the current record's description equals a new resource that's a constant called description, right? The data type is text, and its value is Apex hours are awesome. All right. So if the stage changed, we set the description. Okay, cool. Now, always the final step whenever you're doing a before insert or before update flow is to add to the new list after the flow is complete. Add to new list. Add to new list after flow. So the new list after flow is going to add the current record that we're looping over. Okay. So that always must be the final action. So that's true if the stage changed or if the stage did not change. Okay. So what are we doing here? Let's make this look a little prettier, right? For each record, we find the old version of the record. Then we compare the current stage to the old stage. If it changed, we set the default description. And then no matter what, we need to add those back to the new list after the flow is complete. The new list after flow stores the state of the new list when this particular flow is complete. And that's what's used to apply record updates back to the field updates back to the record during before insert or before update context. So let's save this flow, call it the description flow, op description. Okay, save it. Let's activate it. All right, cool. So now it's active. We'll go to custom metadata types. All right. We'll create a new record in the trigger action. Create a new one. This is going to be the op description flow. That's the name of the flow. The trigger, the Apex class name is trigger action flow. This is going to be the first thing that happens before update on opportunity. Okay. Sets a default description if the stage changes. Now we'll save it. All right, cool. So just to recap, right? We wrote this flow in a particular way where we're able to fetch the old values of the record. And this is basically a very applicable workaround for the lack of is changed or prior value in auto launch flows. This is completely safe to call within a loop because all that it's doing is finding the same record out of the old list, and then we assign that value to the variable that we called old record. Now, if the stage changed, we set a default description. No matter what, we always need to store the state of the new list after the flow is complete. So we always do that. That's the final step in the loop when you're before insert or before update. So here we go. It's all set. Let's go back to opportunities. So here's our hello opportunity, right? If we take a look at the details, we can update this opportunity, right? So let's give it a type, right? We'll save it. We see that it still has no description. However, if I change the stage name, we'll see now we have a default description is set for us using trigger action flow, using flows that are auto launched, where we can still fetch the value of the old value of the record before the transaction or before the flow started. So using this really means that you can use the trigger actions framework, and you can tell your admins to write their flows in this particular way, and you can let your developers write individual Apex actions, and then there's no longer this religious debate about which one's right. You can still work together as a team and maintain control over the order of execution and see all of the things, the universal view of all of the automation on the opportunity S object here using these related lists on the S object trigger setting itself. When we're iterating over the list of same records, will that not increase the Apex CPU time? So when you iterate over a collection of records, right, in computer science, we talk about things that we use big O notation, which means the theoretical limit of how long it would take. If we wrote a for loop over 200 records and we wrote 1,000 for loops, that's still big O of 200. It's still big O of the size of the list. It actually takes about 2 to 3 milliseconds to perform that loop. So computationally speaking, the time necessary to loop over those records is pretty negligible. Are there any gotchas when adapting existing code to the framework? So one thing that I've done in the past for migrating legacy trigger actions or trigger logic into this framework is I just create an individual action that contains all of the legacy stuff. So there would be one action called legacy trigger handler before insert, legacy trigger handler after insert, legacy trigger handler before update. And then as you add more actions, you can then just choose, do those things happen before or after that legacy one? And then you pull things out of the legacy trigger handler into individual trigger actions, and then you have that universal control. It's actually relatively easy to migrate to. Cool. There are a couple of other things I want to just touch on real quickly, right? Take a look at this documentation. You'll see like the stuff that we talked about is in here, right? So here's the project, right? Opportunity trigger handler, new metadata trigger handler.run, one-liner of this. The stage insert rules, prevent the stage from being inserted unless it's prospecting, right? All of this stuff that we went over today is still present within the README, right? It shows how to modify the S object trigger settings, how to add particular individual actions, right? Support for flows, how to set up your flow variables. Here's an example. Has the stage changed? Set the default description, add it to the new list after flow. So all of this stuff that we went over today is present in the README, and this video is going to be shared as well. So you should have all the reference material to go back and revisit some of these topics in the future. One thing that I frequently get asked is about recursion prevention, which we already went over, bypass mechanisms, which we already went over. One thing that I frequently get asked about is repeated queries. So in the documentation, right, let's just say you're on opportunity and you need to fetch attributes from the parent account records. You don't want to be querying for the account S object multiple times. So I've got an example in here where we use the singleton pattern to execute our queries, and then you specify that as the first trigger action that happens, and then those query results are available for you for any subsequent trigger actions. So standardized name happens after the queries, but then you can use the queries get instance before account map to store the values of those queries and then use them in subsequent actions. And you can also use a similar strategy for if you have multiple actions which update parent accounts, for example. Maybe you use the singleton pattern or static variable to hold, say, a map of ID to account for all of the account modifications that you're going to do, and then the very final action would be to update those the account map values. So there are some things to help you avoid running into governor limits, DML limits, SOCWA limits when utilizing the trigger framework itself. Can you please explain how to bypass the trigger for a particular profile or user? Profile or user, what you do is you use the bypass permission. So you enter in the API name of a custom permission, then you add that custom permission via permission permission set assignment to a user, or you add that permission directly to the profile itself, and then that will bypass execution for anybody with that permission, and that's how you would do it for an individual or for a profile. So if you have a data integration user or a data integration profile, you use the bypass permission API name, assign them that permission, and then the actions will be bypassed for them.
So there is any guideline like what should be the permission set name, or we can give any permission set name and put it over here?
Any permission set name. All this doesn't care about the permission set name. It only cares about the actual custom permission name itself. So any mechanism that you use to assign that permission could be a permission set assignment, could be a permission set group assignment, or it could be directly a profile level permission. As long as the user has that permission, it will be bypassed. Any way that you give it to them is totally fine with the framework. Cool. I'm going to go back into the presentation. Now, so here's the here's the architecture that we just talked about. Now there's one or two other things I want to talk about. The first thing is working together in teams, right? So if you take a look in your project directory, you'll see that there's an SFDX project JSON, and that allows you to specify the package directories that are applicable to contain metadata that will be deployed to your target Salesforce environment. So if you use the trigger actions framework, you can partition your trigger logic into individual business units or individual applications or features, and then deploy them individually while still maintaining that complete control over the order of execution. So you might have a base package which has like trigger frameworks, HTTP callout frameworks, standard S object, like pick list values such as like stage name or case status. Then you might have a folder that has all of the generic opportunity automation that applies for every opportunity in the system. Then you might have a folder that's particular for the retail team and a folder that's particular to the wholesale team. So you can use the package directories array to partition your application logic and still maintain control over the order of execution and not have to worry about dependencies when you use the trigger actions framework. Another thing that you might have noticed, let's get out of presenter mode, is that on each one of these trigger actions, the order is not an integer, it's actually a decimal. That's for two reasons. One is if it was an integer, and let's just say you had 10 trigger actions and you wanted one of them to happen after the fifth one, but before the sixth one, you'd need to shift all of the ones down. So it's a little bit of a mechanism by which you can insert things in between trigger actions. So it'll give you a little bit more flexibility to not have to shift all of your order indices down. But a second reason why that is because you can use that as basically a team prefix, right? So you could say that retail team, your prefix is 2, and then they have everything to the right of the decimal to control all of the order of execution for all of the retail activities, right? So it could be something like we do all of the stuff with order 1 happens for all opportunities, then wholesale team is prefix 2, retail team is prefix 3. This isn't like a hard and fast rule, but it's just something which might help to work better in teams and be able to give teams the autonomy to specify the order of execution for their particular trigger functionality. And then there's one final thing that I want to show you guys. It's all the way down at the bottom of the README, is DML-less trigger testing. So included in the trigger actions framework is this class called the test utility. It's got this method called getFakeID. What you do is you pass it in an S object type, and it will return to you a syntactically correct fake record ID. Now, if you take a look at the way that we write these trigger actions, we're passing in new list, and we pass in old list as well. The old list is not available before insert, but you pass in the opportunity, the new list and the old list. So when you can pass in those variables that you want, you can then use the test utility to kind of mock out your the record update itself without ever having to insert the record. So take a look at this particular test. What we're doing here is we're getting the fake ID for an opportunity. And we're saying the old version of the opportunity with this ID had stage name of qualification, but the new version is closed won. Then I can call my trigger action itself. So these are the stage change rules, just an example class. And then you can make all of your assertions about what happened without ever having to insert an opportunity at all. So here we're asserting that the element at position 0 has an error. It's got exactly one error, and the error has a message that is the invalid stage change error from qualification to closed won. We were able to test all of our trigger logic without ever inserting any records at all. Now, this is super helpful when it comes to test execution time. DML will drastically decrease the speed at which your tests execute. Now, this isn't a total silver bullet. It won't work well for absolutely everything, but it will help you when it's applicable to test your logic without having to insert or update the records that would have induced the trigger call itself. Super helpful and can drastically decrease your test execution time and the number of ways that the test can fail. Here, there's only really one way that the test can fail, and that's that we failed to add the right error. We don't have to worry about validation rules, process builders, anything else. We're actually writing a true, pure unit test here and not an integration test like we talked about at the beginning of the presentation. So like I said, it's not a silver bullet, but it should help you. It's just another tool in the tool belt that you have with the trigger actions framework to increase the performance of your org, make it so that way the little green circle moves all the way around faster when you're doing deployments. I'll go back to the presentation, and that is the last slide. So I want to say thank you guys for coming and checking out this framework. I'm super excited to share it with the world. I think that this can save so many hours, so many headaches debugging things, and can really set yourself up for a lot of future success, to work well in teams, to be able to really control the application in a much more granular and specific way than we've ever been able to control before. You got the bypass mechanisms, multiple bypass mechanisms, one basically every kind of flavor of bypass that you could want. And then also the ability to bridge the gap between Apex and Flow for record-based automation. I'm really happy to share this with the world, and I'm looking forward to the community's feedback. So if you choose to use this in your project and you find some opportunities for improvement, please reach out to me at Mitch Spano on Twitter. You can find me on LinkedIn. Raise an issue on the GitHub repository itself. Let's actually share that repository in the chat, just so you all have it. It probably should be shared in the meeting invitation itself. Let's see here, give this to everyone. There you go.
It is in the meeting link, and don't worry, we will share the recording and we will share the link into the recording as well. And hopefully soon we will be share one blog post so that you will be able to try it very first time with the help of the blog post and recording.
Nice. Does anybody have any other questions about this particular trigger framework?
And you can directly unmute yourself. I allowed you to unmute. So if you have a question, feel free to unmute and ask a question directly instead of using chat window.
Quick question. I was just wondering if you tried this with async triggers or multiple subscribers to a platform event.
Good call. I have not actually tried this with platform events. However, in theory, it should work with platform events. I personally haven't tried it. If we take a look at custom metadata types, right, these S-object trigger settings, this used to be a metadata relationship to the S-object itself. However, I changed it to just be the string of the object API name in hopes that I'm future-proofing myself, so that way these can be used on platform events. And then for asynchronous triggers, you could have your Apex trigger action just call a future method or call a queuable class as well. So you should be able to provide some sort of asynchronous processing, particularly for, say, after update, you need to make a REST API call out to a system. You can just have a future method that's called from an individual action itself. But yeah, good call on the platform event. I haven't quite done it. It theoretically should work, but I got a little bit of research to make sure that it's good before I like publish it to the world, you know, so.
Any other question from anybody else?
What are the steps we can take to, because not every organization might have followed this approach, right? So what we can take to convert an existing code base into this so that every team can leverage this trigger actions?
Yeah, sure. So let's just say that I had an existing class called opportunity trigger handler, and it had a method, you know, before insert, after insert, before update, after update. Let's just say, for example, those were those 4. What I would do is I would create a trigger action that is for the legacy opportunity trigger handler before insert, the legacy opportunity trigger handler before update, the legacy opportunity trigger handler after insert, and then after update as well. And then each one of those, you'd basically have one trigger action that does all of the logic that's contained in your legacy thing. And then slowly over time, you pull things out of your legacy, that legacy action, into their own individual action classes. That's been a really effective mechanism that we found. The only tricky part that comes with that is what happens if you want something to happen, say, in the middle of your legacy action, then you need to split your legacy action out. That's where it gets a little bit complicated, but luckily, in my personal experience, we haven't faced that issue yet, at least in the projects that I've been working on where we've done this migration. But yeah, the whole point is create a trigger action, an individual action class that just calls that legacy opportunity trigger handler, and then configure it to be one action. And it's kind of just like a big action. And then slowly over time, as you need to modify things, you just pull actions out of that legacy opportunity trigger handler and into individual actions themselves.
Got it. Thank you.
Yep. I think I saw somebody had a question about workflow rules, process builders, and flows. So if you take a look at the performance profiles, you're going to have a very, very strong argument that you should not be using process builder ever, if performance is what you care about. Workflow rules have not received an update from a platform perspective in many, many years. So workflow rules are pretty outdated. So I would definitely recommend it. You know, if you want to tell your admins how to write things in a point and click way, I would tell them to start writing flows immediately and then plug the flows into the trigger actions framework.